Bismillahirrahmanirrahim. In this section, we are discussing or solving some quadratic equations by factorization methods. So, this is uh, in this session we'll discuss x square plus bx plus c is equal to 0 form uh, to solve value of x. So, let's solve this exercise 20.9 from Waters education book and for IGCSE and O-level maths. So this is x square minus 5x plus 6 is equal to 0. We have to divide this into factors of 3 and 2 such a way that we get minus 5. So this is minus 3 minus 2, and when we multiply we get plus 6, when we add we get minus 9. So this is we take out and we have this. So either this is 0 or this one is 0. So if this is 0, then x is equal to 3. If this is 0, then x is equal to 2. Solution is x3 and x is equal to 2. So x square minus 7x plus 6 is equal to 0. X square minus 6. So 6 can be divided into two factors. This is 6 and 1. So when add, we get minus 7. When multiplied, plus 6. Minus 6 minus 1, we get plus 6. So take out this and then we have two factors. So x is equal to 6 and x is equal to 1 is the solution. This one, x square minus 8x is equal to 0, and take out x common, and here we have x minus 8 is equal to 0. So this x is equal to 0 or x minus 8 is equal to 0. If x is equal to 0, then it's 0. So x is equal to 8. So we have two solutions. This is quadratic equation. Quadratic equation always have two solutions, or if a single solution means that solution is a double solution. So similarly for this one, x square plus 3x is equal to 0. So x taken out common, so x plus 3 is equal to 0. So x is equal to 0 or x plus 3 is equal to 0, and x is equal to minus 3. So this solution is x is equal to 0 or x is equal to minus 3. So for this one, it's x is equal to 0 or x plus 6 is equal to 0 means x is equal to minus 6. The solution is this. So for this one, x square minus 10x plus 24 is equal to 0. We take out this two factors 4, 6, and when multiply gets 24 plus 24, when added minus 10. So we have x is equal to 4 or x is equal to 6. This is x square minus 2 to 5. So we have this 25 square and x is equal to 6. This is a square minus b square. We can write down a minus b, a plus b. So this is x minus 25 is equal to 0. X plus 25 is equal to 0. So if this is 0, then x is equal to 25, and if this is 0, then x is equal to minus 25. The solution is x is equal to 25 plus 25 and minus 25. So you can write down like this. So this is x squared is equal to minus is equal to 10x. So we can place this 10x on the left hand side. So this becomes this. We got x common as again, x plus x minus 10 is equal to 0. So x is equal to 0 or x minus 10 is equal to 0. If this is 0, then x is equal to 10. The solution is x is equal to 0 and x is equal to 10. So for this one, this is minus 2. So this is minus 4 plus 3. When multiplied, we get minus 12. When added, we get minus 8. So this is same as this. Take x as the common here and 3 common here. The solution is minus 3. So we have done it this kind of factorization earlier. So now we are just placing this. 24 x square minus 1. So this one x square is equal to x. So we can place this x here. So take out x common, x minus 1 left. So x is equal to 0, x minus 1 is equal to 0 means x is equal to 1. So the solution is x is equal to 0 and x. This is x square minus 17x plus 30. So 30 can be divided into 15 and 2. So when we add it, we get minus 17. When multiplied, gets plus 30. So take the x common here. This is x minus 15 and x minus 2. X minus 2 is equal to 0. X minus 15 is equal to 0. X is equal to 0. X is equal to 15. Solution is x is equal to 2 or x is equal to 15. Now move on to quadratic equations where this x square has a coefficient a. Earlier this a was 1. Now this a is equal to is not 1 but has some other values. This has coefficient 2, 3, 4, 5 or any other number. So now we have this 20.10. So we have 2x square minus 5x is 12 is equal to 0. Now multiply this with this one and we have this 24 and we have to divide the 24 in such a way that we get this minus 5x. So 8 minus 8 plus 3 is, when we add we get minus 5, when multiplied we get minus 24. So minus 12 plus 2, 24. So we take all this and we have this x minus 4 is equal to 0, 2x plus 3 is equal to 0, x is equal to 4, x is equal to minus 3 divided by 2. Solution is this 12x square plus 10x minus 8. When multiply this 12 with the 8 we get some values. So 72. So this is 96, I think so. 96. This is 12 with the 96. So and we have to divide this into 16 and 6. So this is plus 16 and this is minus 6. So we have this minus value, minus 96. So this 12x square plus 16x and minus x minus 8. So we can take out 4x common here. So 3x plus 4. And here we have 2, minus 2 may be taken common from this. Minus 2 is taken common, so 3x is left here, and the minus common, so plus we have, so when multiplied it we get minus 2 plus 4, multiplied gets minus 8. Check it early, check it many times because this kind of error may be performed by the students. This is a high-end error. So 3x plus 4 is taken common and the x minus 2 is equal to 0. So this is we can take out 1, 2 from here common. So this becomes 2x minus 1. We have this is 0 and this is 0. So this is 0 and x equal to half, and if this is 0 then we will say minus 4. So let's say this 5x square minus 125 is equal to 0. So 5 may be taken out common here. So x square minus 25 is equal to 0. So this 5 is equal to 0. So this is not. So divide the whole equation with 5. Here 5 and here divide by 5. So this will cancel out, and here 0 divided by 5 is again 0. That's why we have this. So you factorize it. X minus 5, x plus 5. So this x minus 5 0, x plus 5 0, x equal to 5 and x equal to minus 5. This is the solution. So now we are moving toward the completing square method. So we cannot factorize it easily. So this is 4 and this is 6. We cannot get this minus 6 with this 4. So this would be a difficult one. So for this kind of problems where the factorization is not easily possible, we perform completing a square method, solving quadratic equation by completing a square method. So it's a kind of using or performing quadratic formula. Actually, we are actually performing the quadratic formula. So we are building it actually. So we are not directly using it direct formula, but we are manipulating this quadratic equation in such a way that we get this kind of formula. So this is x square minus 6x plus 4 is equal to 0. So this is x. The first term, this we have to make this a complete square. So we take out here x square, and here we have 2, and then this x here, and to make it this minus 6, we have this 3 here. So when we multiply this 2 with 3 and x, we get this minus x. From this term we have this. So here we have another term 3, so we will write here 3 square. So this will make a complete square. So this 3 square is added, so this 3 minus 3 square will be subtracted, so make it balance. So this is extra, so this will cancel. This 4 is here. This is the. So this, from the first two terms we make a square up till here. This added and this subtracted to make it a perfect square. So up till here we have a perfect square, and this will be merged with this one. So you eventually have this x minus, this is a minus 2ab b square. This is a square minus 2ab plus b square. So from this a minus b whole square, a minus b whole square, a minus b whole square. So this is minus 9, and so we have this. So x minus 3 square, here we have minus 5, so this minus 5 on the right hand side plus 5. So taking a square root on both sides, this is x minus 3, and this is under root plus minus 5. So we place this x3 here on the right hand side, x equal to 3 plus minus under. So this is the solution. So we can write 3 plus minus under root 5 is the solution. So we can say 3 plus under root 5 and 3 minus under root 5 is the solution. Similarly for this one, x square plus 10x plus 5 is equal to 0. So we use these two terms to make a perfect square. So this x square plus 2 x and then 5. So 5 with multiplied with 2, 10, 2 is gets 10. We have this. So this 5 square here and then minus and then remaining. So from the first three values we have a perfect square, a plus b whole square, and this is 25 and 20 minus 20. So minus 20 placed on the right hand side, so it's plus 20. So taking square root, x plus 5 is equal to this 20 is 2 under root 5. So this is 4 into 5 is 20. When taking square again, this is 4 and this is 5. 4 5 to 20, so it's, so we have this value, and this 5 may be placed on the right hand side, becomes minus 5 plus minus 2 under. So the solution is x is equal to minus 5 plus minus 2 under root. Similarly for this one, question number 6, x square minus 5x plus 2 is equal to 0. So this is x square minus 2x, and then this becomes 5 by 2. This may be right away 5 by 2. So this is 5 by 2. So this is 5 by 2 square minus 5 by 2 square plus 2. So from this to here we have a minus b whole square. So this is a minus b whole square. This is 25 upon 4 and this is plus this. We take out the LCM here, and 4 to the 8, and this is minus 17 upon 4. This is x minus 5 upon 2 whole square. So this 17 by 4 may be placed on the right hand side. So this x minus 5 upon 2 square is equal to 17 by 4. So taking square root on both sides, then this becomes plus minus under root 17 divided by 2. So we place it on the right hand side, then 5 upon 2 plus minus 17. So this 2 is at the denominator. We take the LCM. So write down like this. So this is 5 plus minus under root 17 divided by 2. Solution. This is the solution. This is also a solution. We may leave the solution here. This is also. So take this one, 3x square minus 4x minus 5. So 3 under root 3x may be placed in this place, in this location. So this is under root 3x whole square minus 2 under root 3. This is here. To make this 4x, we may write down 2 upon under root 3. And this under root 3 will cancel out that way. This much. And then since we have placed it here, so we plus this 2 upon under root 3 here. So minus also. So this is minus 5. And, similar procedures are adopted here. So we may take out this under root 3 so common, so x minus 2 divided by 2 minus on 3. This is 3 5 is 15 and that's 90. So this is one of them. Similarly for this one, there is another method to solve this, is completing square, and you will see it later. So this is 5 square. So this is under root 5 and this 5 under root 5 divided by this. So this is minus 6. So this is a plus b whole square. So we take out this under root 5 common square. So this is x minus 3 upon 5. So this is 5 square is 5. So this 5 will appear here at the bottom. So this is, we take out the square root and we get this. The solution is 3 upon 5 here. So we take the LCM. So 3 plus minus under root 29 divided by 5 is the solution. We can solve these things with some easy way as well. So we'll see it later. In equation 1, this is x square plus 12x plus 12 in the form of x plus m square minus m. So we have to write this into this form. This is again a completing square method. We can previous question can be solved this way as well. All the previous questions from 1 to 14 we can perform in this way if this is a coefficient 1. So this is x plus m whole square minus m. So we can write the, and hence they state the minimum value, and also state the minimum value of this x square plus 12x plus 12. So using, we cannot factorize it easily. We cannot get this plus 12. So using your answer to the part A or otherwise solve the equation is to give your answer in the form of p plus minus under root q under root 6. So p plus minus, this is q and then under root 6. So we will perform this equation part A. So this is, so we have to write this in this form. So we will take this and we will write this in this form. So we are equating it to this one, and this is x plus m whole square. So we write down it here, x square and then this 2mx plus m square minus m. So we compare the coefficient. So this is 1, so 1 here. This is 12 is equal to 2m. 2m is equals to 12. So we can write 2m is equal to 12. This we are equating because this x has a coefficient 2m and this x has a coefficient 12. Both are equal, so this 2m is equals to 2m is equal to 12. So we can write it here. Similarly, this m square minus n is equals to 12. This is a constant term that is which is equals to 12. So we can write it. So from this, m is equal to 6. So we will place this m here. So this is 6 here. M 6 square minus n is equal to. This is 36 minus n is equal to. This is 36 minus 12 n is equal to 20. So we may write this in place of this 6 and in place of this is 24. So when we write 24 here and 6 here, we will have x square plus 12x plus 12 is equal to x plus 6 whole square minus 20. So this is the way that we have achieved this. This is x plus m whole square minus n. This is the form that was required. So this is also again a completing square method. This is the same was performing in the earlier questions. So this is again a completing square method. This is completing square method. So we may perform the all earlier problems in this way as well. So this is easy one. So this is the solution. Now we can say that the minimum value of this y is at x equal to minus 6. When we say this x is equal to minus 6, this becomes 0 because this term will always be positive. Only at x is equal to 0, this value will be at minus 6, this value will be 0. At x is equal to minus 6, this value will be 0. Otherwise, this value will always be greater than 0. This will be positive except at x is equal to minus 6 where the value will be 0. So the minimum value of this expression of this factor is when the value of x is equal to minus 6. So the minimum value of the y is at x is equal to minus 6. So when we place this minus x, this becomes 0. So this becomes minus 20. So we can also plot it like this. So when x is equal to minus 6, the y is minus 20. And when x is equal to 0, when x is equal to 0, when you put x is equal to 0, this becomes 36 minus 24, that is 12. So when x is equal to 0, the y is 12, 0, 12. So we have plotted this. This is a parabolic curve. So in a part C, using your answer to part A or otherwise solve the equation this. Give your answer in the form of this. P plus Q, P plus minus Q under root 6. This is under root 6. This is Q. This is P plus minus. So we have this factor. So we have this. Taking square root on both sides, and this is x minus 1. So this is plus minus 2 under root 6. So this is P, this is Q, this is under root 6. The solution is this. That was the required solution. Now we are going to solve this equation. This one. So this is 2x square plus 8x plus 5. We are completing square. We are completing square. This is another way of completing. So this is very simple. So here we can write a here and then ax plus b whole square plus c. So we will open it. So this is x square plus 2xb 2bx and then b square and then this c. We multiply with this a with the whole term and x then c. So this is ax square, this is 2abx, and then ab square plus. So now compare coefficient. So this a is equals to 2, easily visible, and then 2ab is equals to 8. This is 2ab is equals to 8, and this a plus ab square plus c is equal to 5. So we can say this a is equal to 2. So in place of a we can place 2. So it becomes 4. 4b is equal to 8, means b is equal to 2. So this b becomes 2. So in place of ab square we can place this value of a here and value of b here. So this 2 and 2 square plus c is equal to 2. This is 4 into 2 is equal to 8 plus c is equal to 5. So c is equal to minus 3. So we can place the value of a, b and c. This a, b and c in its respective positions. So we place this 2 here and b here, and c minus e is here. So this becomes 2x square plus 8x plus 5 becomes 2x plus 2. This is a, this is b, and this is c. So this is completing square. So this is, we can see this is completing square. So we can perform this kind of factorizations to make complete square. In an earlier problem we can adopt this method. This is easy, this is more easy than what we did earlier. So we have this. So this is one of the way. So in this way we have to compare it, and we see that for part B, that is a different one. So part B we have solved this again. We have this similar kind of problem. So this is again completing square. C, we did the same. Now solving using quadratic formula. This is 20.12. We have x square plus 8x plus 6. We will get the similar kind of results. We are doing, actually this is completing square to get this kind of result. So we use this formula directly here, and this is a is equal to 1 and b is equal to 8 and c is equal to 6. We will place this at respective position. So in place of b we will write 8 here plus minus. In place of b we write 8 here, and then 4. A is 1 and c is 6. So this is 64 minus 24 is plus minus 8. So this is 40. This is 2 under root 10. 2 may be taken out common from here. Minus 4 and plus minus under root 10. This may be cancelled out. So minus 4 plus minus under root 10. This is the solution. We actually get this kind of solution for this kind of problem with completing square method. So this is again the same, but we are applying directly the quadratic formula. Usually in a O-level exam we do not apply this kind of. We actually perform perfect completing square method to get the solution like this, which is equivalent to this one, but we do not perform this kind of operations in O-level exams. We actually perform to make it complete square. So actually we derive this kind of formula and get this. We have performed this kind of solution earlier. So we can in our practice session we can compare these or perform this kind of quadratic formula and completing a square method together to see that we have the similar kind of results. So this is 5x square minus 12x plus 5 0 to 0. And here we have this 5 minus 12. Placing at a respective position, make sure the signature or sign, plus minus sign, is very, very important. This at place of b, you will write minus 12 whole square. This is a is equal to 5 and this b is equal to 9 and c is equal to minus 6. So this is b square minus 4a, and in place of c we'll write minus 6. So this minus 6 will becomes plus 6. 4 5 the 20, 20 into 6. So this is plus. This is 5x square plus 9x plus 3 is equal to 0. A is 5, b is this, and c is equal to 9 minus b plus minus b square minus 4ac. This is 8160. So this is 40. Now some word problems. This is very important. A garden is 8 meter long, longer than its width. So the width is suppose x. So the length is width plus x, width plus 8. So this is length is 8 meter longer. So the width is this, then the length will be x plus 8. So the area is 25 meter square. So when we multiply length into width, we get the area. So when we will multiply this x with x plus 8, so get the area. So this is simple. Now this we have a simple formula, x square and this 8x, and then we shift this minus 25 to the left side, we get this. So we may factorize it, or we may use the quadratic formula to get the result. So this is quadratic formula here. So a, b, and so we get this quadratic formula. This is minus b plus minus, this is b square minus 4 a and c. This is c minus c 25 minus 25. So this 6. So we get this. So x is equal to this one or this one. So this is not possible because this is negative value, and here we have a dimension should be positive. So we'll ignore this one. So this is not possible. So this is the solution. So this is minus 4 plus under root 41. So x plus 8 is equal to 4 plus under root 41. So add this with this x, we will add 8. So this becomes, so this is the length and this is the width. Width was initially assumed as x, and the length was x plus 8. So this is the length and this is the width. This is width. So this was the solution. Now a rectangular pen is constructed along an existing wall. So this is a wall, and we have constructed this fencing. We place this fencing here. So this is x, this is L, length L. So this length, so the wall with a fencing of 20 meters. So this is 20 meters. So 20 x plus 2L. So this is 2x, and for this there is no fencing required. So this length will be covered here. So we have 20 meters. So 20 meters is equal to this length x and x. So this is 2x plus L is equal to 20. So L is equal to 20 minus 2x. So this is 20 minus 2x. So this length is basically 20 minus 2x. So in place of this length we have this, and this is x. So when multiply x with L, we will have area. So this area may be written down as this. So this is another point formula. So this part A, it was required to find the variable in forms of area. So this is area, right? So part B, write an equation and solve it to find the dimension to give an area of 40 meters square. Suppose this is equals to 40 meters square. So if this is equals to 40 meters square, then we count this. We shift it here and we take out 2 common here. So this is x square minus 10x plus 20. So apply the quadratic formula and get the result like this. So this is the length. Width, actually it was x, so we obtained x, and from x we can obtain L. So first we will obtain x, and then L is equal to 20 minus 2x. So this is the length. The x and length is obtained. So this was the required problem. And then part C. So let's move to part B, part A, part B, and then part C. So we have to find the maximum area for this one. So this is x square. So we have this formula, and then we have this. So x is equal to 5 and y is equal to minus 3. So we'll place x when x is equal to, in place of this, when x in this formula, this is this. So when we place so this one is equals to this. So we have this. Let's suppose this, we have this one is equals to y. So if this is y, then if we place x is equal to 5, then y becomes minus 5. This is the minimum value. So this is 0. We have performed this kind of things earlier. So this is in place of x will be 0, then this becomes this. So this is 20, and so this is 0 and 20. When we place x is equal to 0, then y becomes 20, and when we place y is equal to 5, here we have 5, x is equal to 5, then y is equal to minus 5. So this is the minimum value. So at minimum value, this area would be maximum. When x is equal to 5, when x is equal to 5, the length would be 10. So this is area would be maximum at this. So for this value, we will get a maximum area. So x is equal to 5. At x is equal to 5, the area would be x into L, and that is 50 meters square. So this area by covering this with 5 into 10, we get this 50 meters square. This is the best possible solution by using 20 meter fencing. So this we will use x 2 times and L is 1 time. Make sure this is a very practical problem. This is S line, this is 10 meter, and this is 5 meter and 5 meter. So this is 20 meter length. So here we have 5 meter, and this is 10 meter. So this becomes 20 meters, and we'll get a maximum area. If we reduce it, then we'll see that this is less than this, and this is shown here by this curve. Here we have different value. You can just plot it at different values here, and get that the area would be minimum, would be different than this. Here at this point, the area would be maximum. So this x value 5, the area would be maximum. Now 15, a rectangular lawn measuring 22 meters. This is rectangular lawn by 15 meters. This is width is 15 meters, and we have to, and surrounded by a path x meter. This is a footpath, of course, x meter width. We have to solve this equation to form and simplify an expression for the total area of lawn and path. So we have to total area this lawn and the path. So this total area is equal to this 22 meters. Here we have this x length, here we have x length. So 22 plus 2x, this is this, Similarly, for this 15 meters, this is 15 meters, and this is x, and this is x. So 15 plus 2x. So 15 plus 2x. So when multiply, we get this. So this is the total area. This given information, the total area is this. This is very important problem. This is very practical and very important problem for the examination point of view. So this is this. Write an equation and solve it to find the width of the path correct to the nearest centimeter. The total area is. This total area is assumed as 400 meters square. Then we have to solve the value of x. So this is 400 meters. This area equals to 400 meters is given in part B. So solve it and we will get this. So we have this quadratic equation and we can solve it. X equals this. So this solution is 0.9 meters. So this area is basically 0.9. This footpath is 0.9 meter, less than 1 meter on all sides. So make if we take this minus 0.9 meters on all sides of footpath, then we have this area equals to 400 meters. This is very important and very practical problem. Suppose you are just solving this kind of problem in your area. You have a garden and you have to draw a footpath, and you can calculate the materials or measurement to build this path. Suppose you are placing some tough tiles here, and you have to find out the area of this one, or the perimeter or length or number of tough tiles required to build this kind of structure. This is very practical problem. I advise all my students to solve these kinds of problems and get the mastery on it. So you can have better understanding of the power of quadratic equation and completing square method to get the results of the quadratic solutions. Very important. So that's all for now.